Hello.
Howdy.
Hi, hi.
Zoom really chops off trying to wave one's hand.
At least your camera is working. Mine isn't.
Oh no. Normally I work remotely, but I'm actually in our company's office today and realized, oh, I need a virtual background or you're going to have lots of people moving behind me.
I like the soothing space. Yeah, image. It's a good pick.
Cool. It was my attempt at capturing the aurora back when
Oh,
it
did you
was.
take this picture yourself?
Yeah.
Cool.
There you go. That's more spacey as
Ooh,
well.
fun. We're
Yes.
getting this live photo slideshow behind you.
So, do you remember when I complained about my camera not working 5 seconds ago?
Looks like it's changed its opinion.
Yeah, you should remove this thing from your camera.
Mine at least is very obvious on the local MacBook camera. Let's see. There we go. Oh, actually, it's not with the virtual background, but it's a pink sticky note. So usually if I see the pink, it reminds me. Cool. Looks like we're getting a good group of folks, good quantity of folks joining.
Tuesday.
Uh,
Sure.
for the agenda today, I think we've got two updates to KEPs, and I would love to walk folks through what my team does. I
Awesome. Yeah, it looks like you're up first.
cool.
So welcome everyone to the Tuesday, March 18th, SIG Multicluster meetup. Clay, take us away.
Awesome. Thank you. So I'm going to do kind of an abbreviated presentation that I hope to present in London next week at the Cloud Native Rejects conference before KubeCon. But I would love to make sure that I am properly understanding some of the technology, some of the proposals from SIG Multicluster in particular, because I love how it's guided our team in some of our development and how some of the development of our processes have kind of been concurrent with SIG Multicluster. So with that, let me walk through how we use CRDs for and kind of the data architecture around them for multi-cluster Kubernetes management. And just double check everyone can see my screen okay? Awesome. So kind of, key thing for a lot of us, I think there's a number of folks who are cloud operators on the call in particular, is managing Kubernetes clusters at scale. So we have that exact same problem, and we want to manage all of our software platforms that run on Kubernetes with Kubernetes. So being a Kubernetes first software organization, CRDs and controllers, and trying to think, how do we manage clusters in those patterns is really a key part of our kind of ethos for my team. And some of the relevant pieces, therefore, are those CRDs that make up what a platform and a stack is. So you'll hear me throughout this talk quite often talking platforms, tiers, and clusters. Those are kind of the basis for how we view what we do for managing Kubernetes clusters. One of the interesting things that we do is the API server that stores this data. Effectively, a Kubernetes cluster is a database, not actually running workloads. And then the controllers to kind of affect our broader world, right? We're a large enterprise here at Bloomberg, 8,000 some developers or more. And so we have to affect our broader world outside our team and outside of that Kubernetes cluster that stores data or any one of those platforms, as well as we have software that follows kind of a controller pattern, but isn't technically a controller to affect those clusters, which are running various platform software. So you'll specifically see these CRDs mentioned. The other kind of key things where we run into some SIG multi-cluster similarities is particularly each platform is decomposed into a tier, which then has a cluster set. So very similar to SIG multi-cluster, slightly different semantics potentially. And then we have a concept called a compute namespace. So we need to deploy many hundreds of Kubernetes namespaces, but there's a lot of metadata in our enterprise, and I presume most, that kind of apply to a namespace. And so we have a CRD that represents that called a compute namespace. One theme you'll see throughout this slide deck, anywhere where I'm talking of upstream Kubernetes or upstream SIG multi-cluster, it'll be in orange. So CRD is a general Kubernetes concept. Anything that is Bloomberg specific and kind of how we're doing things to try to disambiguate between, say, a SIG multi-cluster cluster set and a Bloomberg cluster set will be blue for Bloomberg. So with that, what are these platforms and how do they work? So we've got many different platforms such as Apache Spark running on Kubernetes, another platform for Apache Flink, of course Argo. In our case, we've got to have some workload stuff, and Argo is huge on that. Then we also have a lot of data science-y workloads such as Jupyter running on Kubernetes. Of course, we're really large in the Kserve community, so we've got Kserve running for model training and then inference with Kserve. I guess 9,000 engineers now, we keep growing. But with that, we need to decompose these platforms and scale across all of them. And we call this our managed compute layer. That is all of the CRDs and controllers on the back end. So as we decompose this, like I was saying, we've got tiers of platforms. So each of those Spark, Flink, et cetera, platforms are composed into tiers. Those tiers are contained within a platform so that we then have clusters underneath each tier. We definitely want clusters as cattle, not pets, heck with pods and things like that. Each cluster should be able to be torn down and replicated and stood back up very easily. We want to manage these clusters in aggregate by tier, and kind of akin to SIG multi-clusters namespace sameness principle in a cluster set. Across a tier, we have a cluster sameness principle. Each cluster within a tier needs to be homogeneous. If a cluster supports some workload, it has Argo CRDs on it, any other cluster in that cluster set should have those same CRDs, right? It should be able to operate the exact same types of workloads. That doesn't mean that they're the exact same size. If you've got some specific type of GPU in one cluster, you should have those same types of GPUs, but you may not have quite the same quantity across that cluster set. So kind of an interesting abstraction that we found is very similar to the namespace sameness principle, but in this case, you could call it a cluster sameness principle. Now, it's worth pointing out, because of that clusters as cattle, not pets kind of philosophy, a tier ends up being kind of the highest level in the hierarchy, if you will, to define a lot of useful configurations. Because of that cluster sameness principle, access policies all should be the same. Ideally, resource usages. Quite often, different clusters might be in different, for lack of a better term, availability zones. So you really want to make sure that, back to my point of GPUs and having the same number, if a cluster should evaporate, you really want its partner pair to be able to to be able to hold it, or its partner pairs, however many clusters might be in that cluster set. And similarly, network controls. You don't want to have maybe the same Argo CRDs deployed on a cluster, but all of a sudden you've moved a pod to a different cluster, and now it can't reach the same network resources. Again, in a big enterprise, you tend to have a lot more network controls than you might have in some clouds, though certainly a lot of people can configure the network pretty restrictively. And so it's worth pointing out, we've got this diagram here kind of showing, platforms at top level, but then within a tier, you've got different cluster sets. You'll quite often see that you might have a development tier for that runtime team. This might be where the newest version of Flink or Spark is running. It's really internal to that team. You may then have an end user development tier, and so that might be your dev or your QA tier, where folks are still iterating on their application. They don't have any users on it. But then you start to have a beta tier where maybe there's some usage, maybe internal usage, what have you. And then you might have a production tier or many production tiers. And it's worth pointing out again to that availability concept. Within that same cluster set, if each level here is a cluster set, you may have many clusters, or you may even have many cluster sets, right? So it's worth kind of just visualizing that, how that might work for your organization, but it's how we decompose a tier under a platform in ours. So let's talk namespaces. Again, namespaces on a runtime cluster are where everything happens, right? If you've got a Spark job, you probably have resource constraints, memory, CPU. If you've got an inference job, you might have GPU constraints. With that, that's all controlled at the namespace level usually. So namespaces are really kind of the end goal of what my team needs to think about, how we provision and make it consistent for these platform teams. And so with that, we want to let them deploy applications blissfully for me and my team. That is out of scope. If you're the Apache Spark team, you figure out how to deploy Spark jobs. If you're the Apache Flink team, you figure out how to deploy Flink jobs, Kserve, Argo, etc. So I don't concern myself, and this talk won't concern us with applications. The namespaces are really kind of the terminal end goal of our deployments here. But as we think about cluster sets being shards within a tier and having one or more clusters per cluster sets, we need to think that kind of the fact that these namespaces are deployed on each cluster in a cluster set. What are we thinking about with these compute namespaces? I mentioned that CRD earlier and how this affects applications. So those compute namespaces define a lot of other Kubernetes principles. You'll see, for example, service accounts defined there. What is actually going to be available to run jobs in a namespace? Limit ranges, resource quotas. To some extent, potentially RBAC overrides is how we do that. And we'll talk at the end of this talk about kind of how RBAC ends up in a cluster. And then there's business logic. You've got who actually owns this namespace? Who do I reach out to in the middle of the night? A lot of things that are very enterprise specific, but this really wraps a Kubernetes namespace object, if you will. And for those who maybe are not quite, with especially this abbreviated speed, grokking the platform tier cluster set division, you can see here a diagram of how a Kubernetes namespace, here namespace A and B, kind of basically roll up through a compute namespace and are deployed onto or associated with a cluster set and then deployed onto a cluster. So let's talk now, abstract back out from the Bloomberg side of things. We've kind of given a quick flyby of the Bloomberg goals, but let's talk SIG Multicluster real quick and some of the KEPs and definitions from SIG Multicluster and make sure that I'm understanding them right. In particular, we'll cover namespace sameness, multi-cluster service API, cluster inventory. And it's worth calling out, if I understand cluster ID right, we actually don't really follow that because cluster ID is what runs, in our case, on the platform clusters. And as we'll see here at the end of the talk, we try to keep our platform clusters really pretty opinion free. We deploy onto or objects are deployed onto a platform cluster, but from within the platform cluster. So we could care less if that platform cluster really knows who it is. And if I understand the cluster ID KEP, that really is more about that platform or that application cluster, the runtime cluster, knowing who it is. And so I don't think we have a good parallel there.
That's right. Yeah, just clarifying, that's right. And it's not, we led, just for some context, we led with the cluster ID there as like a who am I, what is my name kind of thing, but it could also be used for like other important self-identifying, like location identifying criteria that just Kubernetes doesn't have a way to service today.
Cool, thank you, Jeremy. Yeah, and that makes good sense. It turned out, it was funny as I was going through, because I really wanted to make a link to every SIG multi-cluster item I could, just to hopefully be valuable of what we've done for a couple years here at Bloomberg, for if there's any lessons we've leveraged, or just to provide the community an awareness on how to leverage SIG multi-cluster. So I wanted to be explicit here. I don't have any great ideas on cluster ID. It's a very cool cap and very useful, certainly to be able to have that awareness, so you can drop an application in a cluster and that application can just kind of hydrate knowing where it's at. In our case, we interestingly haven't yet had a use case for it, but instead we leverage the other depths, caps and definitions quite a bit. So let's dig into cluster sameness real quick. Oh, excuse me. My slides are out of, I will have to fix that. You also are getting the dry run of my talk, so my apologies for my confusion in this case. We'll dig into cluster inventory and cluster profiles first, apparently. So one of the interesting things here is with cluster inventory, we've got some very key metadata that we store about a cluster, such as the display name of the cluster manager, what is actually managing the cluster, status of the cluster, certainly Kubernetes version is really useful. Similarly, conditions such as whether it's got a healthy cluster, whether it's joined into a cluster set, joined into the cluster manager. And then cluster access, such as how do you want to actually talk to that cluster? And so that's a very key part of the cluster inventory, is talking about the three different models here of, is it pulling the data with Work API, which is kind of what we do in some ways, or is it pushing into that cluster with identity federation, or just a static secret or some sort of secret credential? In our cluster definition, so our CRD, which is similar to cluster inventory's proposal, the metadata.name of our CRD is just simply that display name. We don't have too much formality around that. The cluster manager is relatively implicit, because we just have this one process that we follow, but the status does line up quite a bit. Kubernetes version is something that a runtime team would have to concern themselves with, so we are less concerned about making that organizationally explicit, but we do have administrative statuses, such as whether that cluster is inactive or active, or trying to pull off some Kubernetes terminology here, cordoned if for whatever reason applications should not be deploying to that cluster, and then certainly deprecated or decommissioned for the state of getting rid of a clusters from the current list. Similarly, administrative status messages we found to be really useful. We have a tool for users to very easily get access to a cluster, and this provides kind of a central publication source for where, what the status of that cluster is, why it might be deprecated, or why it might be cordoned, so that users are aware of that and they can bubble that up as they see fit in their infrastructure. Similarly, cluster access, very similarly, whereas there's the three models, we've kind of implicitly chosen the pull model in many cases. We'll get to that at the end of my slides, but here, cluster access really matters in a lot of ways. We need some way to publish certificates, and this seemed like a very easy way to do that. Network proxies, again, big enterprises, you often have proxies, we do. But then server URL, just how do I find this, right? Even if you're putting your API server in DNS in a really easy to find way, how do I know that unless I am opinionated about those DNS names? In our case, we can't be. So the actual API server URL is very useful to publish there. And then authentication configuration, is it doing some sort of OIDC or some sort of other token exchange process? So how do you access that cluster? Similarly, cluster sets. So this is an interesting term because it is well-defined in SIG multicluster here between the multi-cluster services API defining that within a cluster set, the namespace sameness principle applies, and all namespaces within that cluster are really considered to be the same. Cluster set, excuse me, are considered to be the same. Similarly, you've got to definitely understand what is in that cluster set, which clusters belong to it. In our case, we definitely do. But SIG multicluster, rightly so, says, hey, look, we aren't designing your system for you. We're just giving you the ideas. So that is out of scope for the proposal. And then cluster inventory nicely explains the namespace sameness principle implies that a cluster can only be a member of a single cluster set. Otherwise, you run this risk of collisions, is my understanding. So for those who maybe aren't familiar with cluster sets, here we can see how this works for us, that you might have the Apache Spark platform. Here you'd have a dev interactive and a dev batch tier, and then you'd have a cluster set with clusters A and B in each tier. So different clusters A and B here probably should be A, B, C, and D. So let's talk about namespace sameness real quick here. Again, SIG multicluster definition is that the permissions and heuristics for that namespace are consistent across clusters within a cluster set for a given namespace. Those namespaces don't have to exist in every cluster, so it is possible that you could have a namespace deployed and it's not in cluster A, but it is in cluster B on a cluster set. But they do need to behave the same. And we actually require that in many ways. We'll use cluster sets for sharding a tier. So, maybe you've got 3 or 4 clusters, and actually let's take an even number of clusters. You got 4 or 6 clusters, but you need to shard those namespaces, right? You don't have one cluster that can handle all of the workloads for that tier. So very valuable definition. Ours is kind of achieved implicitly by that compute namespace being at a tier level. So, if you've deployed a compute namespace at the dev tier, then it goes across all of the cluster sets it's assigned to within that tier. Similarly, this in our case allows for consistent namespaces. So kind of back to the diagram here, explaining that compute namespace is linked to a cluster set and then used to deploy into clusters. Cluster name is an interesting part. It's a unique identifier for a cluster. It's linked into the registry. Again, we don't have multiple implementations of a registry here. In my team, we have one that we've chosen or written. Similarly, the cluster name must be a valid RFC 1123 DNS label, which is true for the metadata.name as well. So kind of a nice implicitness for RCRD spec in this case. And similarly, you don't want to change a cluster name throughout its life and membership in a cluster set. So seems like a very straightforward, good definition, certainly applies for us well. So we've adopted it. This is kind of where some of the key SIG multicluster terms are just kind of walk through, because I think a lot of folks may come to Kubernetes and not be aware that these have been formalized if they haven't heard of SIG multicluster and haven't thought to look for these. And so any other enterprises building a similar cluster registry hopefully would be able to be aware. And I want to highlight the nice work of SIG multicluster in this. So with that, let's dig into data and storage, because sometimes it feels like we maybe do things a little weird, or just I haven't heard a lot of people talk about it. It's worth pointing out that SIG multicluster has this great term called hub cluster for the central management cluster of a management system. In our case, it's the managed compute API server, but very much the hub cluster. One of the interesting things mentioning that our hub cluster is actually a storage cluster. We use Kine for that. So Kine we'll dig into, but it's kind of interesting. We end up using an API server as a database. And that means we have to think about referential integrities of CRDs, which is something I hadn't heard a lot of talk about. So want to just bring that concept up. So let's dig into cluster inventory here real quick from SIG multicluster. Basically, all the cluster profile objects need to be deployed to, if you will, a dedicated Kubernetes cluster, that hub cluster. And one of the key things here, basically, that you can then run a controller to be able to operate over it. And we very much do. So here we can see that managed compute API server, or our hub cluster, and kind of looking into it, you can see that we've got those platforms deployed. They're a cluster level resource. We can see the tier resources deployed here. Again, a cluster level resource, but they are linked to a platform. And then with that, each tier will then actually make a namespace in our hub cluster. So here we can see that clusters, cluster sets, compute namespaces are all namespaced CRDs, whereas, like I said, tiers and platforms are not. And it's worth pointing out that for the slide, dev and beta are just bare words, but you do actually have some namespacing necessary, right? If 2 different platform teams wanted a cluster a tier named dev, they'd collide because this is a cluster-wide resource. It's not namespaced. However, within the tier namespace, they could have, everyone could have cluster A and B if they wanted. So similarly, we've got a CRD for our cluster sets and a CRD for our compute namespaces. So one of the key things with the hub cluster that we found is we need high availability. We don't want a resource, an availability zone to take away our hub cluster, and all of a sudden we've lost our control plane. So for that, we use Kine. It's a shim from the K3S project to translate etcd APIs to basically a traditional relational database. They support SQLite, MySQL, Postgres. Nats is, I don't think, a traditional relational database, but they call it out. I will as well, just because that was a new one for me. But in particular for us, we've chosen Postgres. We've got a great Postgres team. They provide us very nice high availability Postgres across many availability zones. So we use Postgres as our backer here instead of etcd. And Kine, therefore, is storing everything that etcd normally would for our hub cluster. Kine certainly works for basically any K8 API server. It is a subset of etcd, and it basically just translates all the transaction calls, so create, update, and delete, to the relational database, in this case, of our choice. So that means we can actually store all of our CRDs, basically using the API server as a RESTful API into a relational database. We've got a ton of CRDs. Here's a nice view of our CRDs again, talking about how platform and tier work, and then cluster, compute namespace, and cluster set link in. Here I've tried to use kind of an ERD style crowfoot notation to be able to show foreign key and primary key relations using those CRDs. But Kine basically makes sure that that hub cluster stores this data for us and makes it accessible. The funny part is, with these CRDs linking to each other or referencing each other, we actually have to think about referential integrity. We can't have a tier that belongs to a non-existent platform, or a cluster set potentially with cluster set that doesn't exist, with clusters thinking they belong to it. And I haven't heard a lot of talk about this, and maybe that's just my ignorance in the Kubernetes community, but we do achieve the same way you would have primary and foreign key requirements in a database, kind of enforcement and implicit updates through cell expressions. We can at least make sure that data is well formed with Kubernetes cell expressions in our CRDs. But then we have webhooks, which will ensure that if you try to deploy a cluster to a non-existent cluster set, right? We go hierarchically. You start with a platform, then a tier, then cluster sets, and then clusters, and then deploy compute namespaces into those cluster sets. So we have webhooks that ensure the object you're referring to actually exists, or that you aren't deleting an object that has references to it. And then we have controllers for external relationships. So you'll see here, such as contact info, on-call groups, or owning user IDs. And of course, Bloomberg, we're a large enterprise. We have databases that maintain these things, so that in the middle of the night, our triage teams can find who might know how to fix the system very quickly. But we actually have controllers that reach out with APIs to our internal systems to be able to achieve that. So it's kind of interesting. I haven't heard many people think about CRDs and their database constructs or equivalents, but we do. And so let's talk resource creation. Again, this is out of spec from the SIG Multicluster opinions on work, but there is the explicit thought of, is it a pull model, a push model into a platform cluster in our case? And here we can see, again, on the right is our hub cluster. We've got our platform and our tier and the various clusters, cluster sets, and compute namespaces. It's worth pointing out those compute namespaces are a CRD we've written. They are not directly applicable to a Kubernetes namespace resource. So we have a translation service that's pretty thin that simply translates that compute namespace CRD into a Kubernetes namespace resource. And we have a very simple replicator that we've written. It's not open source at this time, but replicator that reads that translation service's JSON output or JSON output, and then applies it to the Kubernetes API server. So we can make a change in our hub cluster, update one of those compute namespaces. That replicator runs on a frequency, and then is able to apply the change to a namespace. Similarly, for OPA, it actually becomes really kind of neat in this way that we've got a fair amount of OPA usage internally, which means we can create bundles very easily. We then have an OPA bundle that that API can also reference, and we now have it provide RBAC cluster groups, cluster bindings, things like that. And we can apply that to the Kubernetes API server to create those cluster role bindings, cluster roles, and roles. So we're able to update internal out-of-band systems that then dump an OPA bundle, and we apply it to our Kubernetes clusters. So yeah, sorry for the very quick walkthrough, but hopefully that was of use, and I'd love to make sure that I didn't say anything that is incorrect on the SIG multi-cluster side of things. But
No, thank you. I think this is really cool. I appreciate the talk preview as well. I don't think there was anything at all off here. I think it's neat to see the relationship, the concepts that do make sense. I liked your call out about not using the cluster property stuff. Frankly, if you don't need it, great. Like, it's solving a problem a lot of people have. If you don't have that problem, don't use it to use it, right? Like, I think, if I'm completely honest, I think if you can build your infrastructure in a way that doesn't have to care what cluster it's in, even better. That's just hard for a lot of folks, and especially platform tool builders. But yeah, I thought this was really neat. Thanks for giving us kind of a rundown of how you do things. This has actually been something we've been hoping to get more people into the SIG to do for quite some time.
Awesome. Thank you. Ryan, I think you have your hand up.
Yeah, just good talk. Just one. I'm curious about the kind. So you said something about kind is good for most of the HCD, but not all. Do you know, like, specifically, is it not usable for general purpose, but it's okay for your case? So what is exactly the difference there? So what are the that it doesn't it doesn't work?
That's a great question. My apologies to the kind authors if I am incorrect in this. I will try to ensure that I have a better knowledge of that. That's something I have been told by, so my team doesn't actually run any Kubernetes clusters other than our hub cluster. We've got another team that manages that, and I know they are dismissive of kind for an active cluster running pods. I am honestly not sure why, Ryan. I know I wish I had a little bit more time before this talk. We've had one or two instances where Kine and our Postgres database have both seemingly isolated each other. Either Kine didn't reconnect to the database after the database restarted, or vice versa. Kine caused some interesting issues with the database. Haven't been able to figure out what that is. So I think it's mainly just if anything, a fear of the unknown, right? Everyone knows etcd very well for running a Kubernetes cluster, but I don't have any specifics. So I need to make sure that I don't say that during the talk, or else come back with specifics, but I don't have any at the moment.
Just one follow-up, just to make sure. So it sounds like for the hub cluster, from what you have operated, other than those cases, the progress, the DB and the kind of disconnected. Other than that, it seems to be working, right?
It's worked really well. And I think it was in Amsterdam, there was a talk about using a Kubernetes cluster API server. If I remember right, without pods, it was a very similar use case. It didn't quite go into as much depth as I think we operated at. I don't know if that speaker, I wasn't able to get to them before the talk changed. But yeah, for us, it's been really solid, and it's worked really well.
And your controllers do watch, right? It's not just it watch. Okay, cool.
Yeah, so like we have a controller, for example, on the compute namespaces, right? If you update something in our external ownership database, that actually gets reflected in the CRD. And the controllers are similarly watching if you update in the compute namespace, maybe the owner of one of those compute namespaces, it reflects in the ownership database. So it is just like a normal controller. It's using Kube Builder. So
thank you.
Yeah. Corton.
Yeah, I had a question related to your hub cluster. Sorry if you mentioned it already. Do you run multiple hub clusters and try to replicate and maybe leverage Postgres for that, or And would you have leader election, or do you have a singleton hub cluster?
So we have multiple API servers pointed to the same Postgres instance, but the controllers themselves are doing leader election on that Postgres, through the API servers, but they're doing leader election. So we have multiple endpoints you could come in through. Since it's Postgres backing them, it's consistent, but yeah, the controllers themselves do leader election, so we don't have to worry about one availability zone and another availability zone both racing each other. Interestingly, the replicators, you'll notice that I've got multiple blocks for the replicators. Recently, we've been doing some stuff where the replicator doesn't necessarily have to run in the platform cluster. And we've been running those without leader election. They're noisy in their logs because they do race, and sometimes it loses the race, but things are idempotent, so who cares? But yeah, for the controllers, they do leader election like normal controllers. And the API servers are HA, fully active HA. As far as I know, and actually, thank you for asking that question, because maybe the API servers are doing leader election and I'm ignorant of it. I have not researched that actually. I don't believe an API server. I don't believe core Kubernetes has that feature, and we're just running core Kubernetes API servers. Cool. Brian.
So just sorry, the one follow-up with the Corentin's question. Have you ever had a case that you need to replace your hub cluster? So HA, right? So for HA, is that you keep your hub cluster and somehow the databases, because database HA, you don't ever need to switch your API servers, everything controllers, and keep the database there. Is this, maybe you don't have to, but this is something that is that supported?
Yeah, so actually, great question. And let me step back, Brian, because I want to answer a little bit broader than your question, because there's a part that I'm really excited about. I'm writing an API that's right now got to talk into our API server. So our hub clusters are actually small enough that we can run Kind, Kubernetes, and Docker, standing up a Kind based API server, and that's how we actually do local development for all of our platform, all of our controllers, and all of that. And so we can spin those up and down very easily, but that's using just a local, I think it's SQLite database, most likely in the back end. I'm honestly not sure. It's not Postgres, certainly. But with regards to our production hub clusters, we have actually done migrations between different API servers. So those API servers, ironically, run in a Kubernetes cluster themselves. So we're running an API server within a broader Kubernetes cluster that has its own API server. And as we have deprecated the enclosing Kubernetes servers, we've had to deploy our API server for the hub cluster on different Kubernetes clusters. And that's been fine. Same Postgres backend database. Similarly, like I said, our Postgres team's pretty fantastic here. So I believe they've migrated our database backend, and we've just updated the API endpoint, but they've kept the different DNS name, whatever's behind the DNS names in sync, and we've had no need for downtime with that. The biggest challenge is just being a big enterprise, making sure our SSL certs and everything, SNI names and all that work, but the same as you'd have with any web service. Cool. If there's no other question, and actually, is there anything in the chat? Oh, shoot. Ryan, you asked, I wonder if you have a copy of the talk slice that I can share. Could you clarify that by chance?
Maybe it's already in the talk. No, just the slides. The presentation.
Yep. I will. I think Cloud Native Rejects will post them once I've given the talk publicly. So yeah, or more publicly. Let's see. And thank you, Joshua, for pointing out. I didn't think I was besmirching Kind, but Joshua points out that the GitHub still states that it is not usable at all for general purpose etcd. Although it's worth pointing out, not general purpose etcd, but I'm not sure that it's not usable for a general purpose Kubernetes cluster. I will have to look back. Somebody's unfortunately left our company, but I think he did performance tests of Kind versus etcd probably 3 years ago, 2 years ago now. I don't remember what that was. It may be a performance issue or something like that too that may trip you up. But
Slay.
right.
Sorry, go ahead.
Nope. Cornton points out events maybe being
Ah.
excluded. Of course, since we are not running pods, we could care less about some features of Kubernetes, so that may make sense. And Jeremy, if unless you had a question about my talk, I do want to apologize to Cornton and Ryan for taking so long on my talk, and should probably stop sharing and hand off. But
actually, real quick before you do it, just wanted to plug again that you'll be talking about this at Rejects. Maybe you want to add your session information to the notes for anyone who's there the week before KubeCon who wants to go check it out.
Perfect. Will do. I'll do that while we move on in the agenda. Thank you very much for the time, everyone, and the ideas.
Thank you.
I guess I'm next. So I wanted to restart the discussion about what we do with traffic distribution field, and I was looking for like maybe guidance on how to do this. Maybe, I don't know. I was thinking about sending a mail in the SIG network and SIG Multicluster mailing, something like that. Or maybe we can invade their weekly, or they can invade our weekly. I don't know.
Sorry, I don't have the background. Can you give a little bit background of what does this traffic distribution field reside? Is that a gateway API, or where's that field?
It's in the regular services. Now there's a traffic distribution field which has now two possible value: prefer close and same node, I think. And a while back, like, I don't know, maybe 3 months, 4 months, something like that, we were saying that maybe the prefer close field, well, actually the same node didn't exist at the time, was maybe worthy to sync inside MCS API, but we should like probably contact SIG network beforehand, like, and get their advice on the whole thing. Maybe they would want to add, I don't know, other fields. Maybe they don't want that we use their field. I don't know.
Do you have any link to the API so that I can educate myself? I'm still not very
Yeah.
clear.
I can Google
You
it.
can put it into the notes.
Yes. Good point. In the meantime, if someone has other point about that, feel free. But I'm Googling it. I found it. I'll send in the chat first.
Are you typing something? I don't see. Oh, you're typing the.
Oh, I send it in the chat. Yeah, I will add it also to the notes.
I'm putting that into the note.
Okay, thanks. So yeah, but basically that's one of the fields that was added into service, and we never did anything so far about, because, well, MCS API is prior to this, and discussing what to do about it.
Are you talking about making this into our MCS?
I don't know. That's the point of this. So like, because before there was only prefer close, so maybe prefer close made some sense in like syncing it, but same node doesn't really make sense, I guess. And possibly SIG network has also some future plan on other field, which I don't know of. So yeah, but I mean, yeah, intuitively, if you have a prefer clause on a service, maybe it could make up it to its way on the service import. And if your implementation has a derived services, also make up there. Or not.
Does our current MCS implementation or API actually imply that it's a preferred close, so that for the local traffic, does it automatically route to the local cluster? Do we have anything in our current API specification on that? Or in the API we didn't prescribe any that, just say your implementation can do whatever we want.
As far as I know, there's nothing. There's the annotation thing that you could technically use to do something similar, but it's like very custom. And it's actually like the topology aware of the services. It was like with an annotation before, and this is like the next evolution of this, like a proper field, not an annotation. So yeah.
So we are working on the V1 Alpha 2, right? So yeah, we could continue to discuss on that work stream, right? It's kind of getting we have some delay there, but feels like this is something probably close to that work stream, right? It's the MCS V1 Alpha 2. We could discuss whether we want to add that, or at least on the API side. I thought our API had some description on that, but I'm not an expert.
No, there's nothing so far.
Okay.
But yeah, just if what we are adding is like backward compatible and all of this, probably it should not be like in V1 Alpha 2, like we can just add it. If it is, yeah, for sure. We have to bend the version. So so as for the collaboration and SIG network, I guess I will try to send a mail to both mailing lists and see if there is like people saying anything on there. And maybe, I don't know, maybe we should join the SIG network quickly at some point, or maybe it will handle everything by email, I don't know.
One thing I'm not clear about, if this is in MCS API, then why we need a SIG network get involved? It's a purely multi-cluster network API. That's what I don't get.
Well, that was the conclusion last time I talked about it. To figure out at some point with SIG network what to do with it, and it's also their field, and they added like the same node value that I don't think makes a lot of sense in multi-cluster. So I mean, at least we can consult them and see if they want to collaborate on that. Because yeah, otherwise the obvious thing would be to just, if the service has like say prefer clause, we just propagate it, I guess.
So would that be on the service export then in MCS that you would add these? And my apologies, I've been trying to ramp up while this discussion's going on, so my apologies if I'm still behind everyone. But would we be on the service export where we might use some of these SIG network annotations to say like prefer close, for example, to say within the cluster, and then some of the proposals for traffic distribution, I think, would rely on external load balancer configuration somehow, right? Because if I want to say, for example, traffic distribution, I think there was like I don't think it was round robin, but some sort of like traffic distribution system that would require something external to the cluster, right?
Well, I mean so the previous thing was called topology aware, and it was an annotation. This is like a field inside the services. So I mean, getting from there, we can add a field in service export if we want to, I don't know, do something different with the topology aware thing. For instance, I don't know, you might want prefer this cluster with this name, or prefer this cluster with those cluster properties, or whatever. Those things are more advanced and would probably not be inside the service resource. But if we just sync the field, maybe it can stay in the service like resource. But yeah, that's it can be a complex talk or a simple talk, basically.
Yeah, my apologies. I didn't realize. Is there a service resource in one of the SIG multicluster projects, and I'm just unaware of that? If so, my apologies.
No, there's just like the regular service resource, and you have the service export that is just basically a tag on top of the service to say, hey, this service should be exported. And well, recently there was also the label annotation that was added there, but that's the exception confirming the rule, basically.
Okay. Thank you for the
Yeah.
explanation, Arthur.
No worries. So yeah, I will just shoot an email, I think, and see if any people from SIG Network wants to chime in this discussion, and or else, like at the next meeting, we will like restart on our own, depending, well, starting from their advice or just going on off our own way, I guess. Thanks.
All right, I gotta go next, but I don't know if there'll be time. Well, we can keep it for next time if you want to go, Ryan. Maybe, I don't know.
10 minutes, is it enough for you?
All right, let me try. We'll see. Can you see my screen? Is that the right screen? I hope so. Yeah, that should be.
Yeah.
All right, slideshow time. So, been looking into using plugins for credentials for cluster profile. I mean, I'm sure, well, I hope everyone's aware kind of cluster profile is suffering the lack of having credentials. So when you load a cluster profile, you can't really access the cluster directly, at least for a push method. So we're looking on how to issue credentials for it. So some of the requirements I managed to find, I think the controller is not known ahead of time, but the cluster profile manager, or the cluster profile itself, if you will. I think that was one of the big problem in Ryan's proposal last time, and I think where SIGOff was not too happy is like we're creating kube configs, and it was like not that great, and like we would have a hard time tying permissions. So that was one of those. But also each controller should have its own credentials, or the ability to have its own credentials. Then for each controller credentials, only the intended controller should have access to them. Obviously, I mean, it's kind of the, hey, it should be secure type of requirement. We're manipulating credentials and authentication here, so let's be careful. Another must is, I think that cluster profile manager and platform admin should be able to create their own credentials issuance flow. That's kind of to support standard open source feature and welcome new integrations, and not forcing a hard-coded list. Like everyone should be able to do their own thing. I think we want that openness here. And the second part is that flow should be usable without code change by controllers. And I think config change is okay. And what I mean by that is, if you have that custom flow that you designed and you wrote a plugin for issuing credentials for a cluster profile, and you have something custom, you should be able to use the standard controller, a standard multi-cluster controller that supports cluster profile, without having to touch that code. I think editing config should be okay. If you pass, like, I don't know, a different flag, or if you pass a little different configuration to the controller, I think that's okay. But I think on the other hand, changing code is not okay. I think you should be able to use the standard code, so you can do standard releases and all that. And kind of an optional requirement is there could be multiple types of cluster profile. And I think the use case is if you're consolidating an inventory from different platform. Let's say you have a bunch of Azure and GCP GKE clusters. That could be one. Or if you're doing on-prem and GKE, that kind of things, you would potentially have different ways to issue credentials, and you want to be able to support that in your controllers. So that's I think nice to have. It's not necessarily a must, but that'd be nice. So as I got 4 steps, I think, which are questions that we should ask ourselves. The first one is maybe the most generic one: is are we okay with plugin? Is this approach fitting the requirements? And obviously, I think the answer is yes, since I'm proposing it. But make your own opinion and let me know. So the idea is you would have a plugin. So instead of trying to put things in the cluster profile, the cluster profile would just give us clues on what plugin you should use. It'll give us clues on what could work for it. So that could be by its type, and then we would have a type to plugin mapping, or it could tell you exactly what plugin we kind of expect. So that's one of them. It would be the responsible of the controller to ask for credentials. So the controller would read the cluster profile and be like, okay, now I need to get credentials for it. That way we fit with that requirement that each controller has its own credentials, and it's bound to it, because that way we know we just have to give it to the one calling, the one asking for it. And how to get credentials should be pluggable. That's kind of that last point on integrating into controllers as an extension or something that can be plugged with config effectively. So if you have a cluster manager and that matches a bunch of cluster profiles, you could have a multi-cluster controller that reads the cluster profile and decides like, oh, I need to create credentials. I call the plugin and I get credentials out of it. So like that's the simple flow. The step 2, I think now I'm getting to the details. We'll get like the 3 real implementation questions, like how do we call the plugin? And I think what I've seen, I've tried to look a little bit at some example, state-of-the-art type of thing. Exec is used by Argo. The nice thing about exec, you bake it into the image or you put it in a volume, and your controller would directly call it. It's like binary call, right? So it lives within the context of the container, very much the same context. It's kind of simple on that. Unix domain socket is something you see a lot for like CNI, CSI, maybe CRI too. It's very commonly used for plugins in Kubernetes. The caveat is that it requires a service to be run, right? You need to have the socket open on the other end. So you need to run a service for the plugin. So it's a little bit more involved, and then it becomes kind of interesting. Does it run as a sidecar, or does it run as a node thing, as a daemon set type of thing? So that becomes kind of interesting on that front. So and that brings some of the additional questions and how that runs, blah blah blah. And then the last one is like pure REST over HTTP, and then that opens even more possibilities. That it could run outside of the cluster, it could run centrally somewhere, and the controller would call into it and ask for a token. So it's very similar, maybe how workload identities are implemented with cloud and OAuth, right? And you're changing your KSA for another credential. So it's not uncommon to see those kind of things. So that could be how we offer the plugin. Or we could kind of compose, right? You could do exec, but the exec internally, the plugin would call a separate service. So there's also that things like we could technically do the interface. So here I'm only talking about the interface, right? Because if you do an exec, you could technically call a REST behind. Or if you do a Unix domain socket, you could technically also still call a REST behind. So there are some options like that where it was like layering, but we need to pick just the top level interface for the plugin. So then 3 and 4 are going to be inputs and outputs. Inputs, what do we give to the plugin for issuance of credentials? Outputs, what the plugin returns. So for inputs, I was thinking maybe basic control name, who am I? That's kind of untrusted, but let's pass that. That'll help for logging and all that. But especially, I think important, the KSA. This is your identity as a controller. You prove who you are, and holding your KSA for the cluster is certifying who you are. And the target cluster profile, obviously, which cluster are you trying to reach? take that cluster profile, give it to the plugin, and the plugin will figure out how to best issue credentials for this cluster. And we could have specific credentials for each cluster. And the return, I've got two alternatives, and I'm not fully sure, but I'm kind of leaning towards the second. The first one being the kubeconfig. We could return the kubeconfig that could contain the tokens and all that, but that could also contain like more generic instructions. Not necessarily my preference, because if we wanted to build a kubeconfig, it often assumes how the controller is set up, so I'm not entirely sure. The second one being returning the token directly, and we would have potential information about TTL and things like that, and recalling the plugin regularly. But I think that might be easier and more specific. I think that's all I had. Oh, I just had a little example. We could have a property that shows what kind of credentials you're expecting or what kind of plugin you want. And then it could be as simple as this little function at the bottom in the controller. We could have a standard library for it. It's like, okay, get the plugin, and we'll try to retrieve it'll retrieve the plugin name and then get the plugin. Like, so that's the factory that would retrieve the installed plugins locally, or figure out how to call and what plugins it can call. And then it would just, I'm taking the example of exec, but you would call the plugin, pass the KSA, the cluster profile, get a token. Now you got a token, and you can go and you can rinse and repeat if your token expires and whatnot. Obviously, would have to build that. But that's the idea. Sorry, I'm out of time, but that's the idea. Have a look, put comments. I guess we won't talk too much. Oh, I put that. Well, there's a little bit more slides, but this is implementation, how it could look like. Not too interesting. But yeah, just the idea. I think this is the approach where that could unblock us for cluster profile credentials. And I'm looking forward to have kind of an interface here. And yeah.
Very, very good timing with my presentation, because we definitely have that as part of our cluster spec. We support OIDC as an authentication method, and I actually have a pull request out to the non-Microsoft kube login project to support the client credentials API flow. I actually had this discussion with my team too, where I was like, how do we want to support multiple things? Because that replicator component has to be able to talk to an internal identity credential exchange kind of thing that we've got, as well as just general OIDC client credentials flows, kind of per the spec. One of the questions I've got for you, Corentin, just to understand, do you want us to comment on the slides themselves, or
let's start with that. I don't have a cap yet, so I
Okay.
think the slides would be good to gather a little bit of opinions and all that. And I think if we're good with kind of the approach, I'd like to write a cap, but I kind of want to make choices in each of those slides a little bit. Like, do we want to go exec versus, Unix domain socket and rest? It's like, what is really our approach there? Just to kind of narrow down on the cap, otherwise the cap's going to go everywhere.
Strange question is, do we actually have to be opinionated on how a consumer reads it as much as just defining first what data we're going to provide? Because like internally, we've got a tool that users can use to connect to a Kubernetes cluster. It will render a kube config for them, right? But it has to interpret the I'll call proprietary version of the authentication configuration we have. And that authentication configuration, in our case, just specifies the data that tool renders. It would be possible, and in fact, it is possible, some tools do this all in go, so they don't exec out. But that tool that we have to render the Kubernetes configuration files also does our internal credentials exchange. And so the exec calls, ironically, the tool renders a kube config that calls itself to get the credentials. And if we at least have a well-defined specification, even if we don't have consumers necessarily for it, is there a reason to require the consumer? Because like you've got the example Go code that may be applicable to a use case you've got, but does multi-cluster need to care about the example necessarily?
I think what I want is the ability to have the cluster profile written in the same way and for everyone, and that we could say, okay, this is our interface, and the cluster profile tells you how you could call the plugin, and hopefully, like folks that are writing those plugins, let's say Google Cloud is likely to write a plugin for you, and you could just call that plugin. That would be kind of standard. So if you're writing controllers, like if you use that SIG Multicluster library, automatically that plugin, and you just need to have the plugin available pulled in, but they'll use it by default. So you don't have to do anything else. That's kind of the idea. So I'm looking for that interface, I think, and I would like controllers to be all kind of like written the same, and suggest that.
This would be a Go plugin, so kind of a dynamic library loaded style thing, or
Yes. Yeah, and that's why I'm mentioning the exec, right? That way the plugin itself can be written and be its own binary and shipped separately, but then we would have, like, I'm guessing, a Go library on like how would you call the plugin for a cluster profile. And we could have different language for that, but at least the plugin has to be written once. The plugin caller library, that can be specific to each language.
And have you chatted with SIG about your proposal?
No.
Okay, I know when I was talking to him, because the kublogin stuff, I don't have anyone else to really kind of double check my work on the OIDC stuff, and security is always, kind of concerning if you misunderstand a spec. And so I was trying to get SIG to give me a review on that, and I know that they have some opinions around this probably. So I think it might be useful to hear them out, being an opinionated.
And Stefan, I think as you mentioned, kubeconfig off plugins.
Yeah, that's right.
It's I think similar, right? And I think the exec as well. I could be wrong, but I think
the exec. Yeah, but if you do exec, it allows you to do anything else. So you could have REST or whatever hidden behind the exec.
As a behind thing, yeah.
Yeah, but it makes deployment a little bit more complicated because you need to
have to deploy binary.
Have the binary. Yeah.
Right. You need to bake it in the image effectively, right?
Exactly. Yeah.
Which I feel potentially is, at least at the beginning, maybe easier than forcing everyone to have a sidecar or deployed service, right?
Yeah.
So that's the alternative I see, is like for the short terms, it sounds easier. It's true that maybe long term, if you had a central service, maybe it's like everyone has it. It's not really a problem.
Yeah. But my main point, pointing to the client Go credential plugins, is that maybe we don't need to invent anything, because if an exec model is sufficient and the goal is to end up with a kubeconfig, then we could probably just use that, because that achieves the same goal in the end, which is connecting to an API server.
I need to look more into this. Yeah, go ahead, sorry.
Yeah. Sorry about that. I would worry about adoption, would be my biggest concern if we do anything other than like a client Go or Kubernetes renderable output, kubeconfig, excuse me, renderable output. That was one big challenge that I had internally when my team had this discussion, because we were talking about, we've got some CSI compatible drivers and things like that, so we could have done sockets and such, but then it would have required me making changes to Karmada, Argo, all sorts of stuff upstream that just made more sense that I could just poke everyone and say, hey, look, use a client Go kubeconfig, and then caching and things like that can be handled by the exec, like our internal tool, as well as kublogin have caching if necessary.
Yeah, the extra weird thing here is that we need to, I guess, plug the KSA, but we need to know it per cluster profile. So somehow it should be specific per cluster, right?
KSA is kube service account, or?
Yeah, Kubernetes service account.
Okay. So in our case, like our internal tool for that credential exchange can do KSA to various other authentication material. And in that case, if you're a pod running in a Kubernetes cluster, you just look at your secret, right? That's mounted the projected service account token.
Mm-hmm. Yep.
So why do we need to specify a KSA necessarily in the cluster profile?
I mean, if you're doing exactly the KSA is there, you just need to know where it is. But yeah, you could use that, so that's fine. It needs to use the KSA. So it may not need extra things, but it needs to use the KSA. That's what I wanted to call out. But then the other part is the cluster profile. Is I think we need the ability to potentially have credentials per cluster. So we would need to, when we're doing that plugin call or something, we need to know and pass which cluster we're doing it for.
For the cluster we're coming in from, or the cluster we're trying to connect to?
Connect to.
Okay, so if it's connecting to, wouldn't that be part of the cluster profile double check my term right. Cluster profile CRD in this case, right? Because I'd be pulling the auth.
That would be the CRD, but like whatever we're calling to get credentials, we need to know, oh, this is credentials for this cluster that they're trying to get.
Okay, yep. So like in our case, we've got different JWT minters, so I have to tell you which JWT minter you want a JWT from, for example. So that can make sense. Does that need to be at the top level of the specification, or would that be per authentication type, right? Because like OIDC endpoint is needed for an OIDC flow, for example.
My feeling is that if you pass the whole cluster profile, it should be configured such that the plugin would work. So if the cluster profile tells you, hey, use that plugin for me, it should have the right properties that this plugin will need. That's why I think passing the whole cluster profile to the plugin or to the interface makes sense, because that way we don't have to define what extra properties must be defined. The plugin, the cluster profile would have those properties because it tells you to use that plugin.
I worry.
I'm just, yeah, sorry to interrupt, but we're 10 minutes past the time. So in the interest of making sure that, well, we don't keep people too long, and interested people can keep track of the discussion, I'm going to call time. And we can.
Sounds good. I need to run too, actually. So
yeah.
I'll come back next time. Sorry, Ryan, for pushing you out on this one. Let's talk more next time. And thank you, everyone.
Yep. So thanks everyone, and see you in 2 weeks' time. Bye.
Bye.